Hi everyone, welcome to our channel. Today I am going to discuss about the continuation of the series of log analysis related to eNode B. So I am mentioning eNode B, you can see RX and TX related to all the layers, MAC, PDCP and other things as of now what we had a look. So in today's video we are going to discuss about MAC layer. Okay, so as usual I am just trying to search the MAC. Okay, so here you can see, so I have just searched the MAC. I'm taking those things into consideration. So okay, so I'm taking in the new page to understand better. Now you can see these are all related to so these are all the MAC related stuff. Now let's try to understand what is currently happening. So the scenario you already know, it's an L3 call and going into the idle mode, and then paging is triggered, and for that the U is actually trying to make an attempt, again getting connected, and finally it is released. So this is the actual scenario. So for that, initially when the RS connection is ongoing, how the MAC is actually going to behave. So initially basically the random access is actually initiated. So for that, base station is trying to assign one RNTI. Example, you can see in this particular line, adding the user 46, right? So you can see LCID configuration. LCID means basically logical channel ID configurations, and it is bidirectional, mode of direction bidirectional. What is the priority? LCG, logical channel group, which is 0, and right, HARP feedbacks and PRACH. Currently PRACH is actually happening, and now you can see RAR is actually preparing, right? RAR means random access response. RBGs are there, DCAs are there, message grants are there. So you have to schedule actually all these things. That's why it is inside the MAC there is multiple functionalities are there, BSR, SR, HARC and other aspects. But here you can see wherever you see shed, so that is a scheduler job, what actually MAC is trying to do. And other things are actually preparing the PDUs and sending the MAC control elements, preparing the PDUs and the SDUs to the top layer. So depending on the type of data whatever top layers are actually trying to send, or the layers data whatever MAC is trying to receive. So accordingly the MAC is actually prepared things you can see, and let's try to correlate with respect to the timestamps also. So before going to that, I'm just trying to show fundamental things, maybe some parameters you might got. Okay, you can understand better. RNTS are there, CQAs are there, lost MCS, which means the latest MCS also is taken into consideration, because whenever there is any link adaptation kind of situations, okay, or reporting, depending on the reporting, the MCS also might get differ. So that's the main reason it is necessary to get update time to time. Okay, now we are dealing only with the this one, the RNTI 46. Okay, so when compared to the scenario, okay, you can see example, this timestamp I am taking. The reason being actually until here UV is making that particular L3 call and then coming back to the idle mode. That's the reason we are actually removing from the MAC and 5, right, which is 46 we are removing. Now when the paging is triggered, that's why you can see here paging PCH, right? So in the paging is triggered, now it is actually initiating again RACH, but this time with RNTI 47, right? Earlier it was 46. Now until here UV went into idle mode as per the scenario. Then paging is triggered. Then because of paging is triggered, UV has to respond, right? So while responding, it is making an PRACH attempt for that, right? That the CRNTI allocation, this is in the P cell, the CRNTI allocation is 0x47, right? Random access. So these are things as usual. Actually, earlier what we have seen when Mac is actually making an attempt of random access. So random access response SS3 transmission, which is actually right, which is RS connection request at the RRC layer, RRC level, right? And scheduler. Again, these are all similar things. BSR is there, buffer status reporting, uplink, adaptive link, SNR estimations, right? Pushing PDU, contention resolution identity, MAC contention resolution identity, correct? So all these things that you can see, this is again pushing. This is making the L3 call to happen as a part of paging request. UE is trying to make an attempt of random access. After the random access is successful, like contention resolution, if there is any things out there to take care. In this particular scenario, contention resolution is there. (47) uplink BSR. So we'll try to have a look at the coding also later in the some other different coding courses. Then you can analyze. So here only this particular entire lab setup related to only the analysis of the logs and understanding the configurations. Particularly eNodeB we are trying to have a look. Okay, so for the part is 47, long BSR is there, right? It is applicable. Pushing PDU, which is towards the air, right? So it seems to be the same messages, that is with some different values. So what if you try to have a look at the timestamp and map it to the RRC, then you will come to know in which situation we are, whether we are in RRC connected state or L3 call state, activate default bearer, right? Reconfiguration, configuration. For that, how my Mac is actually behaving, what is actually scheduling, right? So example, let's try to see the RRC connection reconfiguration. So this is the reconfiguration, which is 692522, right? So in this, where is the Mac? So Mac is here. For the 46 it is doing. So right now at the NAS level, which is activate default EPS bearer context request, for that RRC has actually initiated RRC connection reconfiguration. Fine. For that, what is the MAC behavior, right? It has to schedule DL, right? For this particular RNTA, mask and DCA, all the details. This is a retransmission equal to 0, which means it is a new transmission. It's not retransmission. And this is about the PDC set symbols. This is the number of bytes, right? And what is there in the buffer, right? All these things that is actually sending. Again, you can see another one at the MAC level. This is at the MAC level. This is inside the MAC and at the scheduler level, right? So I'm just trying to highlight only MAC. Scheduler. It is trying to do the schedule. So uplink scheduler, which means you are expecting the UV to send something, right? Uplink scheduling, adaptive link, correct? So timestamp we will try to have a look now. Reconfiguration, this one, right? For that my Mac is here. So in the Mac I'm just trying to fetch that. This is the one. Pushing PDUs, TTA RX, receiving, number of bytes you are receiving, right? In between, power headroom reports are also there. Right? Okay. So the fundamental thing about the Mac is basically sending the data coming from the top layer and towards the physical layer. And whenever there is an RX operation is ongoing from the physical layer, if you are receiving something, then you should be able to push to the top layer, which is RLC. So these are the main aspects Mac it will do. But what is that? Whether it is DLSH, ULSH, right? All these things that you need to understand more in detail in the 36322. So you can check it out, the Mac video related to 36.5.22, which is a Mac physical layer design course. There you will come to know all the channels, channel mappings, logical channel, physical channel, transport channel, and random access related different functionalities, SR, PSR, PHR, Mac control elements, payload, PDUs, right? Mac PDU or a random access PDU. Right? All these things we will come to know in the Mac details. So the prerequisite for this particular log analysis is you come back with your understanding from the Mac layer design, which is 36.3.22. You can check it out in the video of the Mac physical layer design course. Then it will be very much easy to understand this particular logs, where we are actually going and what we are actually trying to check from the Mac perspective for the corresponding RRC message. Okay, so it seems to be very similar. You may not be able to find out why it is actually coming and all, but we need to map with respect to the timestamp, and we have to check it out against that particular RRC message. So it may not be necessary that it is an RRC message, but because this is applicable for both SRBs and DRBs, so that's why wherever there is an SRB action, then you need to check it out from the SRB perspective. Wherever there is a DRB action, then we need to check it out from that DRB actions point of view, what we are trying to prepare the PDUs of the Mac. Okay. Yeah, so that's all from the Mac perspective, a very basic fundamental. Okay. With respect to the layer specific details, you can check it out in the course video. There much more in detail log analysis will be given. So thanks for watching. I'll see you in the next video. Thank you. Bye.